Welcome to Math with Mr. J.
In this video, I'm going to cover the Pythagorean theorem. I'll start with some introductory examples and a visual representation of the Pythagorean theorem. Then we will move on to a handful of other examples in order to get this down. Now, the Pythagorean theorem has to do with right triangles and the relationship between the sides of right triangles. It's called the Pythagorean theorem because it's named after Pythagoras, a Greek philosopher and mathematician. Let's jump into our examples and see exactly what this all means and looks like. Starting with number 1, where we have a right triangle. Now remember, the Pythagorean theorem applies to only right triangles. Before we get started with the specifics of the Pythagorean theorem, we need to take a look at the sides of this triangle. And we are going to start with this side right here. The side directly across from the right angle. This is called the hypotenuse. The hypotenuse is the longest side of a right triangle, and again, it will be across from or opposite of the right angle. This is something we need to recognize and know when it comes to the Pythagorean theorem. Then we have the other two shorter sides. So this side right here and this side right here. These are called the legs. So this is a leg and this is a leg. The Pythagorean theorem states that the sum of the legs squared will equal the hypotenuse squared. So the lengths of the legs squared, add those together, and that will equal the hypotenuse squared. And that probably sounds confusing worded like that. So let's write it out as an equation. A squared plus b squared equals c squared. So for the Pythagorean theorem, we use that equation. Again, a squared plus b squared equals c squared. Now, a, b, and c all represent a side of the triangle. Let's start with c. Now, c is always going to be the hypotenuse. So let's put a c here. And then a and b are going to be the legs. It does not matter which leg is A and which is B. It will work out the same either way. So let's call this A and this B. So what we are going to do, we are going to use the Pythagorean theorem, the equation a squared plus b squared equals c squared, to figure out the missing side length. This side right here, the hypotenuse. If we know two of the side lengths, we can use the Pythagorean theorem to figure out the missing side length. Let's plug in the information we know in order to figure out the information we don't know. So we have both of the legs given, A and B. So let's plug those into the equation. So a squared plus b squared equals c squared. Again, we are given a and b, so let's plug those in. A is 4 feet, so 4 feet squared, plus b is 3 feet, so 3 feet squared, equals c squared. Now we can work through this equation and solve for c, so we need to figure out what c equals. Let's start with the left side of the equation, so 4 squared plus 3 squared. 4 squared means 4 times 4, so that gives us 16. Plus 3 squared, that means 3 times 3. That gives us 9, equals c squared. 16 plus 9, that equals 25, equals c squared. Now we need to isolate that variable of c and get rid of the exponent of 2. We do that by taking the square root. So let's take the square root of c squared. Now, whatever we do to one side of the equation, we must do to the other. So let's take the square root of 25 as well. Now, as far as the right side of the equation, the variable of c is now isolated. And then for the left side of the equation, the square root of 25 is 5. So C equals 5. Let's rewrite that with the variable first. So C equals 5, and this is feet. So that is our missing side length. This is 5 feet right here. We used the Pythagorean theorem to figure out the missing side length of that triangle. Now let's take a look at a visual representation of number 1 and the Pythagorean theorem. This is going to help us better understand the Pythagorean theorem. For number 1, we had a right triangle with legs that measured 4 feet and 3 feet. The hypotenuse measured 5 feet. So here is that right triangle. Let's find A, B, and C. We will start with the legs. This is A right here, and this is B right here. Remember, A and B are always going to be the legs, and it doesn't matter which leg is A and which leg is B. They are interchangeable, so keep that in mind. And then we have the hypotenuse, which is always C. The hypotenuse is the longest side, the side across from or opposite of the right angle. So this is C. Now let's take all of those sides of this triangle and square them. And we're actually going to make a square on each side. This is A right here. So A. This is B. So B. And then this is C right here. So C. The areas of the two smaller squares, the legs, actually add up to the area of the large square, the hypotenuse. So the two smaller squares combined equal the large square. So the sum of the legs squared, so square those side lengths and add them together, and that sum is going to equal the hypotenuse squared, so that side length squared. That's what the Pythagorean theorem states. So let's square each side length to find the area of each square on the sides of the triangle to show that this is true. For A, the area of that square is 16 square feet. For B, the area of that square is 9 square feet. And then for C, the area of that square is 25 square feet. So again, the areas of the two smaller squares, the legs, add up to the area of the large square, the hypotenuse. 16 square feet plus 9 square feet equals 25 square feet. So A squared plus B squared equals C squared. So it's pretty cool how that relationship works out for every right triangle. Now let's plug in A, B, and C into the equation to write it out that way as well. So we have A squared plus B squared equals C squared. Now we can plug in A, B, and C. So A is 4 feet, so 4 squared. B is 3 feet, so 3 squared, equals C is 5 feet, so 5 squared. 4 squared is 16, plus 3 squared is 9, equals 5 squared is 25. 16 plus 9 is 25, so 25 equals 25. Now, obviously, that's true. 25 does equal 25. So the relationship between the sides holds true through that equation. We have the legs represented on the left side of the equation, A squared plus B squared. The sum of those legs squared was 25. And then the hypotenuse is represented on the right side of the equation. We have C squared. The hypotenuse squared was also 25. So there you have it. There is a visual representation of the Pythagorean theorem. Now let's move on to number 2. For number 2, we have a right triangle with given side lengths of 15 centimeters and 17 centimeters. And then we have a missing side length. Now for this one, we have a leg given and the hypotenuse given. So let's call this A, this B, so this is the missing side length, and then this C. Remember, C always has to be the hypotenuse. And then A and B are the legs. It doesn't matter which leg is A and which is B. Now we can plug in what we are given into the equation a squared plus b squared equals c squared and solve for the missing side length. So a squared plus b squared equals c squared. Well, we are given a 15 centimeters, so 15 centimeters squared plus b squared. We need to figure out what b is, so leave it as b squared, equals c squared. Well, c is 17 centimeters, so 17 centimeters squared. Now let's work through this equation and figure out what b equals. We will start with 15 squared. That means 15 times 15. That gives us 225 plus b squared equals 17 squared. That means 17 times 17. That gives us 289. Now we need to continue to work to isolate that variable. So let's subtract 225 from the left side of the equation. Whatever we do to one side of the equation, we must do to the other. So let's subtract 225 from this side of the equation as well. The 225s on the left side of the equation cancel each other out, so we have b squared equals, and then on the right side of the equation, we have 289 minus 225. That equals 64. So we have b squared equals 64. We need to isolate that variable of b. Since we are squaring b, we have an exponent of 2. We need to take the square root in order to isolate that b. Whatever we do to one side of the equation, we must do to the other. So we have the square root of 64 as well. The b is now isolated, equals, and then the square root of 64 is 8. So b equals 8, and this is centimeters. This is our missing side length. So b is 8 centimeters. There are our first couple of examples. Let's move on to some examples where we will specifically find the length of the hypotenuse, and then we will move on to finding the length of a missing leg. Here are our examples of right triangles, and we need to find the length of the hypotenuse. Now remember, we use a squared plus b squared equals c squared, with c always being the hypotenuse, and then a and b being the legs. If we know the lengths of two sides of a right triangle, we can use the Pythagorean theorem to find the length of the third side. Let's jump into our examples, starting with number 1, where we have a right triangle and we are given the lengths of the legs. The hypotenuse is unknown. Remember, the hypotenuse is the longest side of a right triangle and the side across from or opposite of the right angle. So let's use a squared plus b squared equals c squared in order to find the length of the hypotenuse. Now again, c is always the hypotenuse, so this is c, and then the legs are a and b. Let's make this a and this b. Now keep in mind, it does not matter which leg is a and which leg is b. Now we can plug in the side lengths that we are given and work through the equation in order to find the length of the hypotenuse. So a is 8 meters, so let's plug in 8 for a, so 8 squared, plus b is 6 meters, so plug in 6 for b, so 6 squared, equals c squared. 8 squared gives us 64. Plus 6 squared gives us 36. 64 plus 36 is 100. So 100 equals c squared. Our next step is to isolate c in order to figure out what c equals. So again, we are just working through this equation to figure out c. Since c is being squared, let's take the square root in order to isolate c. Whatever we do to one side of the equation, we must do to the other, so we need the square root of 100 as well. C is now isolated, so we have c equals, and then the square root of 100 is 10. So c equals 10. Let's rewrite that with c coming first. So c equals 10, and this is meters. So the hypotenuse measures 10 meters, and that's our missing side length. Let's move on to number 2, where we have a right triangle, and again, we need to find the length of the hypotenuse. We are given the two legs. We have 10 feet and 7 feet. So let's use a squared plus b squared equals c squared in order to find the hypotenuse. Let's call this leg A, this leg B, and then the hypotenuse is c. Now we can plug in and work through this equation. So for A, we have 10 feet. Plug in 10 for A, so 10 squared, plus 7 feet for B, so plug in 7 for B, 7 squared, equals c squared. 10 squared, that's 100, plus 7 squared, that's 49, equals c squared. 100 plus 49, that gives us 149 equals c squared. Now we have 149 equals c squared, so our next step as we work through this equation is to isolate c. C is being squared, so let's take the square root in order to isolate c. Whatever we do to one side of the equation, we must do to the other, so let's take the square root of 149 as well. We end up with an isolated c on the right side of the equation, and then as far as the square root of 149, 149 is not a perfect square, so we do not end up with a whole number answer. C equals the square root of 149. Now we can write the square root of 149 as an approximate rounded decimal. The square root of 149 is irrational. The decimal never stops and it doesn't repeat. So again, let's round it and we will round it to the hundredths place. So the square root of 149 gives us 12.206, and again, that just continues on. So I'm going to write it to the thousandths place and then round it to the hundredths. So let's round it to the hundredths place. We have a 6 to the right in the thousandths, so this rounds up. So the square root of 149 is approximately 12 and 21 hundredths. So C is approximately 12 and 21 hundredths, and this is feet. So the hypotenuse is approximately 12 and 21 hundredths. Again, this is feet. So there's how to find the length of the hypotenuse. Let's move on to finding the length of a leg. Here are a couple of right triangles, and we need to find the length of a missing leg. Let's jump into our examples, starting with number 1, where we have a right triangle with one of the legs given and then the hypotenuse given. So one of the legs measures 5 yards and then the hypotenuse measures 13 yards. We need to find the length of the missing leg. We're going to use a squared plus b squared equals c squared in order to find the length of that missing leg. Now, as far as that right triangle, let's call this leg A and this leg B. Remember, it doesn't matter which leg is A and which is B. And then the hypotenuse is always C. Now we can plug in what we are given and work through this equation in order to find the length of the missing leg. Now A is the missing leg, so let's keep this as A squared plus B squared. Well, B is 5 yards, so let's plug in 5, so 5 squared equals, well, C is 13 yards, so let's plug in 13, and this is squared. So that gives us A squared plus 5 squared gives us 25 equals 13 squared gives us 169. So let's continue on working through this equation, and we are working to isolate A. We are working to figure out what A equals. Let's subtract 25 from this side, and whatever we do to one side of the equation, we must do to the other. So subtract 25 from the right side of the equation as well. The 25's on the left side of the equation cancel each other out, so we have A squared equals, and then on the right side of the equation, 169 minus 25 gives us 144. So now we have A squared equals 144, and we need to continue to look to isolate A and figure out what A equals. Since A is being squared, we can take the square root in order to isolate A. Whatever we do to one side of the equation, we must do to the other. So we need to take the square root of 144 as well. A is now isolated. So A equals the square root of 144 is 12. So A equals 12, and this is yards. So the missing leg measures 12 yards. Let's move on to number 2, where we have another right triangle, and we need to find the length of the missing leg. We are given the hypotenuse, which is 9 meters, and then one of the legs, which is 4 meters. So let's use A squared plus B squared equals C squared. Let's call this leg A, this leg B, and then again, the hypotenuse is always C. Now we need to plug in what we are given and work through the equation in order to find the length of the missing leg. So let's start with A squared. So we need A. A is 4 meters, so let's plug in 4. So 4 squared plus B squared. Well, B is the missing leg, so let's keep this as B squared equals C squared. C is 9 meters, so plug in 9, so 9 squared. Let's continue to work through this equation. 4 squared is 16 plus B squared equals, well, 9 squared is 81. Now we can subtract 16 from the left side of the equation, and whatever we do to one side of the equation, we must do to the other. So let's subtract 16 from the right side as well. The 16's on the left side of the equation cancel each other out, so we have B squared equals, and then 81 minus 16 gives us 65. Since B is being squared, we can take the square root in order to isolate B. Whatever we do to one side, we must do to the other, so let's take the square root of 65 as well. B is now isolated, so B equals, and then as far as the square root of 65, 65 is not a perfect square, so we do not end up with a whole number answer. B equals the square root of 65. Now we can write the square root of 65 as an approximate rounded decimal. The square root of 65 is irrational. The decimal never stops and it doesn't repeat. So again, let's round it, and we will round it to the hundredths place. So the square root of 65 gives us 8.062, and then that decimal continues. So I'm going to write it to the thousandths place. That way we can round it to the hundredths place. There is a 2 in the thousandths, so this rounds to, or is approximately, 8 and 600ths. B is approximately 8 and 600ths, or 8.06, and this is meters. So the length of the missing leg is approximately 8 and 600ths, and again, this is meters. There's how to find the length of a missing leg. Let's move on to right triangles with decimal side lengths. Lastly, let's take a look at two examples of right triangles with decimal side lengths. We will start by finding the length of the hypotenuse and then move on to finding the length of a missing leg. Let's jump into our example where we have a right triangle and the lengths of the legs are given. So we need to find the length of the hypotenuse. Let's call this leg A and this leg B. And then the hypotenuse is always C. So we are going to use A squared plus B squared equals C squared. Now we can plug in what we are given and work through this equation in order to figure out the length of the hypotenuse. A is 6 and 7/10 feet, so let's plug that in. So 6 and 7/10 squared, plus B is 15 and 2/10 feet, so let's plug that in. So 15 and 2/10 squared equals C squared. Now we just continue to work through that equation until we figure out what C equals. 6 and 7/10 squared gives us 44 and 89 hundredths, plus 15 and 2/10 squared gives us 231 and 4 hundredths equals C squared. Now we can add what's on the left side of the equation. So 44 and 89 hundredths plus 231 and 4 hundredths. That gives us 275 and 93 hundredths equals C squared. Now we need to isolate C and figure out what C equals. Since C is being squared, we can isolate C by taking the square root of C squared. So the square root of C squared. Whatever we do to one side of the equation, we must do to the other. So we need the square root of 275 and 93 hundredths as well. C is now isolated, so we have C equals, and then as far as the square root of 275 and 93 hundredths, that is not a perfect square, so we don't end up with a whole number answer. So C equals the square root of 275 and 93 hundredths. Now we can write that square root as an approximate rounded decimal. The square root of 275 and 93 hundredths is irrational. The decimal never stops and it doesn't repeat. So again, let's round it. Since the side lengths of the right triangle go to the tenths place, let's round this decimal to the tenths place. So the square root of 275 and 93 hundredths is 16.61 and this continues on. So I wrote it to the hundredths place. That way we can round it to the tenths place. There's a 6 in the tenths place with a 1 to the right in the hundredths. So this rounds to, or is approximately, 16 and 6/10. So that means that C, and I will put C first here, so C is approximately 16 and 6/10. And this is feet. The hypotenuse, the unknown or missing side length of this right triangle, is approximately 16 and 6/10 feet. So there is our first example where we needed to find the length of the hypotenuse. Let's move on to our second example where we will find the length of the missing leg. Let's jump into our example where one of the legs is given, that's 8 and 3/10 meters, and then the hypotenuse is given, that's 12 and 6/10 meters. We need to find the length of the missing or unknown leg. Let's make this leg A, this leg B, and the hypotenuse is C. So we use A squared plus B squared equals C squared. Now we can plug in what we are given in order to find the length of that missing leg. So let's plug in 8 and 3/10 meters for A. So 8 and 3/10 squared plus B squared. Well, B is the missing leg, the unknown leg. So keep that as B squared equals C squared. So C is the hypotenuse. That's 12 and 6/10 meters. So plug that in, and that is squared. Now let's work through this equation in order to find out what B equals. 8 and 3/10 squared gives us 68 and 89 hundredths plus B squared equals 12 and 6/10 squared gives us 158 and 76 hundredths. Our next step is to subtract 68 and 89 hundredths from the left side of the equation. And whatever we do to one side of the equation, we must do to the other. So subtract 68 and 89 hundredths from the right side as well. These cancel out on the left side of the equation, so we are left with B squared equals, and then 158 and 76 hundredths minus 68 and 89 hundredths gives us 89 and 87 hundredths. So now we have B squared equals 89 and 87 hundredths. We need to isolate B now. We need to figure out what B equals. Since B is being squared, we can take the square root in order to isolate B. So let's take the square root of B squared. Whatever we do to one side of the equation, we must do to the other. So take the square root of 89 and 87 hundredths. B is now isolated, so we have B equals, and then as far as the square root of 89 and 87 hundredths, that's not a perfect square. So we do not end up with a whole number answer. So B equals the square root of 89 and 87 hundredths. Now we can write this square root as an approximate rounded decimal. The square root of 89 and 87 hundredths is irrational. The decimal never stops and it doesn't repeat. So again, let's round it. Now since the other side lengths of this triangle go to the tenths place, let's round it to the tenths place. So the square root of 89 and 87 hundredths gives us 9.47, and again, this continues on. So I'm going to write it to the hundredths place. That way we can round it to the tenths place. So we have a 4 in the tenths, with a 7 to the right in the hundredths. So this rounds up. This is approximately 9 and 5/10. So B is approximately 9 and 5/10, and this is meters. So the missing side length, the missing leg, is approximately 9 and 5/10 meters. So there you have it. There's an overview of the Pythagorean theorem along with a handful of examples. I hope that helped. Thanks so much for watching. Until next time, peace.